as little icons. Fabulous. Okay, so it is my great pleasure to introduce Dr. James Rice. He got his bachelor's at the University of Alabama and then did a master's at Northeast Louisiana University and then his PhD at Arizona State University. He is a co-I on the Martian rover, and his emphasis has been on geology and strategic planning for the efforts. And so, Jim, take it away.
Okay, thanks, Robert. Well, I guess it's good afternoon for everybody, time zone wise. So thanks for having me on, and I hope this will be of interest and you'll learn something. And so let me get started. I'll go for my first slide, and I don't see it though.
Just give us a minute.
Okay.
There we go.
Okay, you can go to the next slide, please. Well, I've been interested in space since I was 6 years old. And this is a picture I drew when I was 6 years old that my mother kept. And you can probably see it's a good thing I'm a scientist and not an artist because I have no artistic abilities. But I know my interest goes back at least till 6, maybe before then, but I know for certain 6 years old because I was drawing pictures of rockets, and that's I guess a picture of Saturn up there where the rocket's going to go to. But anyway, next slide. Well, if you look at this report card, you probably think this person probably isn't going to end up doing very much or go very far because there's a lot of bad grades on here, D's and F's, and not too many A's or B's or C's. But this is my report card when I was in 7th grade, and my mother kept it. And I knew that I wasn't a good student, but I didn't know I was this bad. I kind of forgot about it. But if you make straight A's, that's great. Keep doing it, and more power to you. But that wasn't my case. As you can see right in front of you there, that was my report card. And but the thing is, I think everybody was put here for a reason, and everybody has certain gifts or talents or skills. And one of the hard things in life is to figure out what those are and how to use them. And I think everybody has dreams. For me, my dream was to work in exploring the universe. And it didn't look like I had a good start, but I knew I still had the dream, even though I wasn't doing good in school. And so I didn't know how I was going to go from point A to point B. It wasn't a clear, easy, straight line for me. And most of my teachers were very good teachers, but I had a couple that I don't think were very good because they basically told me to my face that I was too stupid. I would never work for NASA. And I just didn't listen to them. I knew deep down that what I wanted to do, and I knew I'd have to work for it. But anyway, like I said, if you make straight A's, that's great. Continue to do that. But if you're not a straight A student like me, there's still hope for you because I was able to get through these bad grades, and obviously get a PhD. So I think I did okay. I had 2 brothers and 2 sisters. I was the oldest. They all made better grades than me, but I'm the only one who's got a PhD. So I think I did all right in the long run. Next slide. Next slide, please. That's good right there. Well, that's fine. Anyway, when I was growing up in the 1960s, the world was a crazy place, just like it is today. Not a whole lot has really changed. The United States was involved in a war. It wasn't in the Middle East. It was over in Vietnam. And certain cities and universities had riots and unrest. And there's a lot of bad things going on. There were assassinations of political leaders. But for me, the space program was what I was focused on and what I wanted to do. And I was really lucky because I was growing up during the Apollo program. And as you can see that Newsweek magazine cover with the astronaut in there, I remember when that magazine was out. It was in October of 1968. I was 9 years old. And you can see where it's up there, it says racing the Russians. Well, back in the 1960s, we were in a space race with the Soviet Union to see which country would land the first people on the moon. And at this time, even in 1968, it was not known who was going to win. The Russians, people thought, would probably win the race because they had an early lead. But if you know your history about this is October 1968. By July 1969, the United States landed the first people on the moon, and we won the race. But anyway, the world is always going to be, in terms of upheaval and unrest, there's a lot of crazy things will always be going on. I put this in there. The situations may be different, but the bottom line is the world is a place where a lot of bad things go on as well as good things. Next slide. And this is my room growing up down there. I built model rockets, and the Apollo astronauts are my heroes. You can see there's a book report up there. I try to draw a picture of an astronaut with a spacesuit, and you can see, once again, why I'm not an artist. And I used to build Estes model rockets and fly them, and that's a picture of me in the upper right. I guess I was around 10, 11 years old when I was flying that rocket, getting ready to launch it. And then I put this slide together because for me, it's really a completion of a series of dreams I had my whole life. And then the last picture down there in the lower right, that's me down at Kennedy Space Center. And in the background, it's not a model rocket. That's a real rocket going to go to Mars. And in the nose cone is a Spirit rover that I worked on. So for me, my dreams came true. It wasn't an easy route, but I had a lot of help starting with my parents. And like I said, most of my teachers were good teachers. And I think to get anywhere in life, it's not just you by yourself. It takes a lot of people to support you and help you and encourage you. And that was my case. Next slide. Now, you're probably well aware that we're in the middle of the Apollo 50th anniversary events. And last July, you probably all know, that was the celebration of the first lunar landing, the Apollo 11 mission, with Neil Armstrong, Buzz Aldrin, and Mike Collins. And it's interesting because right now, as we're speaking, we're in another 50th anniversary. Next slide. The Apollo 12 mission, which most people kind of forgot because it was a second moon landing, but the Apollo 12 mission lifted off on November 14th and landed on the moon in November 19th, which is today, 50 years ago today. The next slide. And here's the liftoff. It happened down in Florida, of course, and it was a rainy kind of day. The rocket actually got struck by lightning twice on the way up within the first minute after liftoff. And then the other picture there is one of the astronauts on the moon. This was, like I said, the second moon landing, and the moon landing happened 50 years ago today, November 19th, 1969. Next slide. Okay, getting on to Mars now. Mars has been fascinating for human beings ever since we looked up at the night sky and saw this kind of reddish, kind of cinnamon colored dot. And it was interesting because the color was a little different than most of the stars and planets you see, which are usually more kind of a white or a yellow color, sort of. But Mars was, you know, like almost like a color of cinnamon, and it was really different. And so that made people wonder why was that so different? And a lot of cultures around the world became their god of war. For the Greeks, it was called Ares. The Romans, they called it Mars. And so you can see why the color looks kind of like the color of blood, associated with battles and wars and things. But Mars became a fascination with people, not only because of its color. As the centuries rolled on, we had telescopes looking at Mars. Now, those pictures on the right-hand side are sketches that were done by Percival Lowell, who was an astronomer in the late 1800s, early 1900s. And he thought those straight lines were canals that were being built by an intelligent civilization on Mars. And they were bringing water from the polar caps of Mars down to the desert regions, the equatorial regions of the planet. Well, there are no canals on Mars. And the reason this all happened is there's an Italian astronomer in 1877 who was looking at Mars, and he called these linear features canali, C-A-N-A-L-I. Now in Italian, that means channel, okay? It does not mean canal, but when it got translated into English, it turned into canal. And about the same time, in the late 1800s, the Suez Canal was being built. And of course, to build a canal, it takes an intelligent civilization, namely humans on Earth. So people made the leap and the connection that there must be Martians building canals on Mars. Totally wrong. It was totally a mistranslation that sent us on the wrong path, but it inspired certain people to study Mars. And the next picture, next slide. Some of the famous stories in the early 1900s, science fiction stories, was by a guy named Edgar Rice Burroughs, A Princess of Mars. He wrote a series of books about Mars that really inspired a lot of the early scientists and engineers of the 20th century, who eventually became the founders of, you know, NASA and the space program in this country. So science fiction inspired a lot of people. The next slide. probably one of the most famous books is by Ray Bradbury called The Martian Chronicles. And you've probably heard of that. But you can see even the picture on the cover of the book, they still kind of have the idea of canals and Martians up there. This book was written in 1947. Next slide. And a lot of movies have been made about Mars. I put this one in here. Most people never heard of this movie. It was made in 1964. Didn't have any famous actors really in it. But this movie, Robinson Crusoe on Mars, if you watch it, it's very similar to a movie I bet you've seen called The Martian. Very similar. And it basically, The Martian is this movie updated with better special effects, contemporary actors, and the plot is a little different, but it's basically about an astronaut trying to stay alive on Mars. So very similar to the movie The Martian that came out, I guess it was 5 years ago now. But like I said, the special effects aren't as good as The Martian, but if you watch that movie, you'll see a lot of similarities in it. All right, next slide. Well, I got selected, as Robert mentioned, as a science team member on the Mars Exploration Rover Project. This was the Spirit and Opportunity rovers. And I was the geology team leader on both of these rovers and worked on long-term and strategic planning as well. And so what I'm going to talk to you now is more about Mars, what we've learned from Mars, from our rovers, and from our spacecraft there now. Next slide. I don't know how much you know about Mars, but I'll put this up here very briefly. I don't want to spend a lot of time on it because I know you can read, but I'll point out a couple of key items on here. First of all, Mars is about half the size of the Earth. If you were on Mars, the day would be very similar to a day here on Earth. You can see it's 24 hours, 37 minutes, very close to an Earth day. But a Mars year is very different. A Mars year is almost 2 Earth years because Mars is further from the sun. It takes longer, therefore it means it takes longer for it to orbit the sun. You know, the orbit the planets is Mercury, Venus, Earth, then Mars. The other thing you notice, maybe the gravity, you'd weigh about 1/3 your weight on Mars. For the atmosphere, you're gonna have to bring your own air supply. There's no free oxygen to breathe. And Mars is a very cold place. You can see, a lot of people think Mars is hot, I guess because it's called the red planet. But the red color has nothing to do with temperature. It's red because it's a lot of iron in the rocks. It's basically rusty. But it's very cold. It's a frozen desert world. Next slide. I like this slide because it puts in perspective the sizes of these 3 objects in space. The Earth, obviously. But if you took all 7 continents on the Earth and squished it into a ball, that's the size of Mars right there. If you take just the continent of Africa and did that, squish that into a ball, that's how big the moon is. So that's kind of a neat device to kind of keep the respective sizes of these 3 objects in our solar system in perspective. The next slide. Well, we have a philosophy or a strategy for exploring Mars, and it's basically called follow the water. And as you can see, water is kind of the common denominator through all these 4 major areas of life, climate, geology, and when we get astronauts on Mars one day. Water, there's no life forms that we know of that can exist without liquid water being present. So all life has to have, as we know it, has to have liquid water available. Water is important for driving your climate systems. You know, our clouds on Earth are made of water vapor. The climate on Mars is much simpler, but Mars has clouds. Instead of water vapor, they're ice crystals, but it's water again, help drive the system. And geology is important because when water was flowing across the surface of Mars, it erodes and carves dried up riverbeds and deposits certain kind of minerals. So by studying geology, you learn about the water on Mars. And then the human exploration is very important because, like I said, you have to have water to stay alive. We know there's water on Mars, but it's in the form of ice now. But we can also, the water on Mars can break it apart into hydrogen and oxygen. That's rocket fuel, okay? And if you remember the space shuttle when it used to fly, that big orange tank that the orbiter would be attached to, that inside that tank was the fuel for the rocket, and that was liquid oxygen and liquid hydrogen, basically the ingredients of water. And also, you know, if you have water, you can break it apart to get oxygen to breathe. So the most valuable resource in space exploration is water, more valuable than gold or diamonds or anything like that, because water, you can do so many valuable things with it for life support and rocket propellant. Next slide. Well, the thing about Mars is going there is very dangerous. It's been often called the graveyard of the solar system because most of the missions that have been flown there have failed. You can see 2/3 of the missions that planet Earth has sent to Mars have ended up in failure. And the United States has been the most successful country. However, we've had some failures, not as many as other countries. For instance, the Soviet Union, now called Russia, has attempted to go to Mars about 23 times with missions. All of them have failed, never worked. Whereas the United States, we're the only country that has landed successfully on Mars at this point. But we've had a failure. I know about this one personally, because we've attempted 9 landings on Mars and only 8 have worked. The one that failed was called Mars Polar Lander, and it crashed on Mars. It'd be 20 years ago, this coming up December 3rd, 1999. I worked on that mission, and you spend years of your life working on a mission, getting ready for it. And when a mission fails, it's very disappointing, but you also lose your job as a scientist. So it's a very trying time, and you never hear about this when a mission fails. You always hear about how much money was spent, but you never hear about how it personally affects the people involved on the team, the scientists and engineers. And you really have to have a strong passion and desire to do this kind of work, because you know those aren't good odds. 2/3 of missions failing at Mars, but we continue to try it, and we have another rover that's going to lift off this July called Mars 2020 rover. It doesn't have a name yet. It's going to get a name, and I don't know if any of you participated. There's a contest. I think the contest ended in about a week or so ago. For K through 12, you could send in your names for the rover that will be, I guess they'll pick the name, I'm guessing, probably sometime this summer before the liftoff. And this rover will land on Mars on February 18th, 2021. And we know that precisely because of orbital mechanics, Sir Isaac Newton and Johann Kepler, these scientists that lived hundreds of years ago. So on February 18th, 2021, we are either going to successfully land another rover on Mars, or we're going to make a crater on Mars. There's no two ways about it. So hopefully it's going to be another success for NASA there. But as you can see, you know, these aren't slam dunks. It's very difficult to get to Mars. Next slide. Well, a little history of Martian exploration. The United States was the first country to send a spacecraft by Mars. It flew by the planet in July of 1965. And this was called Mariner 4. And this is it sent back about 21 pictures. And this was one of the pictures. You see it's kind of real fuzzy, kind of grainy looking. All you can really see there are craters. And this was kind of disappointing because this looked a lot like the moon at the time. And people were like, oh, they thought Mars was going to be a little different. Maybe there was a chance for life and stuff, but it looked very disappointing. And this was 1965. Next slide. But the United States didn't give up. They flew 2 more missions to Mars in 1969, a couple weeks after the first moon landing. So people kind of forgot about these missions, Mariner 6 and 7. And this is a picture. Once again, you see a lot of craters, awful lot of craters. And I can't point it out on the screen, but if you look towards the middle part of the lower middle right of the screen, if you have good eyes, you can see like a little squiggly line kind of curling through there. Right there. No one really noticed this at the time because the craters got everybody's attention, and they thought it was kind of a barren world, very similar to the moon. But 2020 vision is very good because now we know what that is. We have better pictures of that. That's one of the dried up riverbeds on Mars. And it's a shame that it wasn't really, we didn't get better pictures. And there's other areas on Mars that have even more of these. Next slide. But Mars also has these giant dust storms. And when Mariner 9 got there, the United States keeps sending missions to Mars. This was launched in May of 1971, and it went into orbit around Mars. Those other missions were just flybys. They flew by the planet, clicked pictures as they zoomed by. Mariner 9 was going to be the first spacecraft to ever go in orbit around another planet. So on November 13th, 1971, Mariner 9 arrives at Mars, and it gets there. There's a giant global dust storm going. So you can't really see anything on the surface. It's just bright and dark markings, all you see. But about 3 or 4 months later, the dust finally cleared. And the next slide. They saw this. This was one thing they saw, a giant canyon going across the equator of Mars. The Grand Canyon would be one of those small squiggly lines down there in Arizona. But this canyon is so big, it stretches from the east to the west coast of the United States, about 2,000 miles. And it dwarfs the Grand Canyon in my home state, where I live now in Arizona. But this was a massive feature, and it's too bad those earlier missions didn't see this, because if it would have, I think the interest in Mars would have been a lot more than it was. We probably would have landed people on Mars by now. Next slide. Now, if they'd have seen this, I think we would definitely would have been on Mars, because this was from the Viking mission in 1976. And you can see a lot of dried river channels there, dried river, and even some areas where there were lakes, craters that had channels flowing to them, and they ponded up and formed lakes. So if this would have been the first view we got back from Mars, or first views, I think our whole exploration strategy would have changed, because Mars would be looking like we know it is today, very Earth-like. Early Martian history is very much like the Earth. And that makes you ask the question, well, was there life on Mars? Well, as I speak to you today, we still don't know the answer to that. We're getting a lot of clues. It looks like it's very favorable conditions, but it doesn't guarantee life got started. But it looks like Mars had all the building blocks for life to have formed there. And personally, if you ask me, I think it's going to take astronauts up there to answer this question, because looking for fossils, these would be like microfossils, small organisms, if there were any on Mars. It takes a lot of hard effort, cracking rocks open, probably drilling into the subsurface. And I just don't think machines are good enough to do that. I think people are the best explorers. And once we get astronauts up there, and hopefully some will be trained in geology, which I know they will be, because it'll be important, I think that'll be our best chance of trying to find any evidence for past Martians, or maybe Martians that are living there today. But like, once again, when I talk about Martians living today or even in the past, these are primitive microscopic organisms. No plant or animal life ever got started on Mars. So just didn't get going for whatever reason. Next slide. This is a picture, and if you don't know what you're looking at, it's hard to tell. It looks like abstract art, but this is a picture taken from orbit. So you're kind of like a bird's eye view looking down the planet. And this is a spacecraft currently in orbit around Mars. I told you previously, those were the historic missions, the Mariner and Viking missions. But this was from Mars Reconnaissance Orbiter, a camera called HiRISE. And the details here are so great that you could see a tabletop. You can see your desk sitting on Mars. That's how good the resolution is. So what you're looking at, the light colored stuff is the top of a plateau or a cliff, and you're going off the edge of a cliff as you work to the right. And then down the bottom, those are a bunch of sand dunes that are kind of darkish blue-gray. And then if you look at those rocks, you're looking at, once again, like the cliff side of a rock, you're seeing a lot of layers in it. So you're seeing a lot of geologic history there. And if you know anything about geology, you know the oldest rocks are on the bottom, the youngest rocks are on the top. So if you were there walking around, you would know it's a great area to take some samples. You get the real old rocks, and as you progress up on top of the cliff, you get the younger rocks. You'd sample those and take them back to laboratories, and you get the exact date, how old they are, and what minerals are in there, and if there are any fossils in there, for instance, you could look for that. So next slide. This is a picture of a dust devil. Here in Arizona, we have a lot of these in the summertime. You probably don't see too many of those in Washington unless you're out in the eastern part of Washington. Like, I don't know, I've been to Moses Lake and the area out there. I've done a lot of field work out there in the Quincy Basin, and you can see these out there. But this is a picture looking at a dust devil and on Mars. And, you know, if you've ever been to Arizona, it looked very similar to Mars. The colors, the rocks are kind of a reddish, you know, orange, brown colors, similar to Mars. We get dust devils out here because I live in a desert. Mars is a desert world. It's a frozen desert. But there's no signs of life on Mars, so you wouldn't see any cactus or anything like that. Next slide. Here's a picture taken from orbit again, and you can see the tracks of the rover I worked on, Opportunity, coming up to you're coming across a plateau of sand dunes, and then you come to the edge of a cliff. That's an edge of a crater. You can't really tell it because it's only a small fragment of the crater. You can see a segment. You can see our rover tracks, and if you look real close, you can see our actual rover sitting there, Opportunity, right there on the surface. And Opportunity was about the size of a golf cart. But if you look at that picture, you know, you can see things smaller than the size of a golf cart in there. So it's a great camera. It's the most powerful camera ever flown to Mars. And it's been working up there since the year 2006. It's returning a lot of useful information for scientists. And then just nice, cool looking pictures for anybody to look at. Next slide. These are the landing sites that we've landed on Mars. And the one I left off, these are the successful landings. The one I left off was the one I worked on that crashed, and that was down near the South Pole of Mars at the bottom. But these are all the ones that have been successful. InSight landed not quite a year ago, last November 26. And then the Mars 2020 rover, when it lifts off this summer, The launch window is between July 17th and August 5th. It's going to launch between those dates, where we'll have to wait 26 months for the planets to realign to go. It's going to land kind of a little further in the northern hemisphere, off to the left of the Viking 2 site, to the lower left of that kind of. So that's where the rover is going to land on February 18th, 2021. Next slide. This was the first successful landing on Mars. It was by a spacecraft called Viking 1, July 20th, 1976. And these are the first color pictures ever returned from the surface of Mars. And sure enough, it is a red planet. This landing was supposed to happen on July 4th, 1976. And that was the bicentennial of the United States. You know, the US was 200 years old. And if you look in that picture in the upper right, you can see the bicentennial star symbol that was mounted on the windscreen. Yeah, right there. But when the spacecraft got there, it noticed the original landing site looked very rocky and rough. So the scientists spent a couple of weeks finding a safer looking landing site, and they landed on July 20th, which actually worked out to be pretty neat, because July 20th, 1969, that's when man first landed on the moon. So July 20th is a big red letter day for NASA for space achievements involving the moon and Mars. And so that was the first successful mission. Next slide. This was the first rover to ever land on Mars, and this was in 1997. This was July 4th. We finally got our July 4th landing 21 years later, but this was Mars Pathfinder, and this rover is very small. It's the size of a little, portable microwave oven, weighed about 20 pounds, but it was the first successful rover to work on Mars, and it laid the groundwork for all the rovers that came after it. Next slide. This is the current missions that are operating at Mars and some that are planned in the future. I've mentioned a lot of them already. You can see a lot of orbiters up there. They're mostly NASA, but there's a couple of European orbiters there. India has one up there. I don't know if it's still working or not. It's called Mangalan, if I pronounce that right. Then you can see Opportunity down there, but it quit working last February. And Curiosity is still going. InSight, I mentioned that one. That landed last November 26th, not quite a year ago. The ExoMars rover got pushed to 2020, so it's not there. It didn't get there. It got delayed. And you can see the 2020 rover. These are launch dates. Like I said, it's going to land in 2021. So 2020, this summer, is going to be very busy for Mars coming up summer, because NASA, we're going to launch the 2020 rover. The Europeans and Russia is launching this thing called ExoMars rover. The Chinese are launching an orbiter, a lander, and a rover. And then the United Arab Emirates are launching an orbiter to Mars. So Mars is going to have a lot of traffic come the first of the year in 2021. It takes that long to get there. If you lift off in the summer of 2020 and you arrive in the first of the year in 2021. But it's going to be a busy place. It's a busy place already, but it's going to get even busier. But you have to remember, 2/3 of the missions fail out there, and it's not a guarantee that any of these missions I mentioned are going to work. It's not a slam dunk. So follow those, and I'm sure they'll be in the news a lot as those missions progress. Next slide. Now, I'm going to talk about the work I did on the rovers, because I worked on those rovers for over 15 years. Next slide. This was Spirit and Opportunity, twin rovers that were sent to Mars. They lifted off in July and June of 2003, a long time ago. Some of you probably weren't even born then. Probably most of you weren't. But this rover was the size of a golf cart. It was solar powered. It had 6 wheels. It had science instruments and cameras all over it, because it was there to do science, mostly geology. And you can see there's an arm on there. It's called the IDD, the Instrument Deployment Device. And that is about the size of a human arm. It had a shoulder, an elbow, and a wrist joint. And instead of fingers, it had like instruments out there. And I won't go through all of them, because I know you can read those, but those instruments, so spectrometers, they would measure the rocks in the soil and tell us what they were made of, what minerals and elements. So that's how we know that Mars definitely has a lot of iron and sulfur in the rocks. And it's interesting, if you were on Mars and you out there walking around, you brought some rocks inside your lander when you came back, because you wouldn't want to do this on Mars, there's no air to breathe. Once you get back inside your habitat and if you took the Martian rock out, it's probably going to smell like rotten eggs, because there's a lot of sulfur in Mars, and a lot of sulfur in the rocks, along with iron. Those are kind of the main ingredients for the Martian rock. So Mars probably smells like rotten eggs, if you could smell it. So it's probably not the best smell, but like I said, if you're walking around on Mars, you're gonna be in a spacesuit because there's no oxygen, free oxygen to breathe. So you'd only smell it when you got back inside your capsule or lander. And if you brought your suit in there, you might smell it in the dust or the rocks. But other than that, you really wouldn't have any indication of it. Next slide. Well, these things kind of happened. We didn't plan this to happen. We developed a philosophy. The MER stands for Mars Exploration Rovers. That's Spirit and Opportunity. And it started with good leadership at the top. And Steve Squires was the leader of the science team who I worked for. And he was a great leader. And it just, we had a great team of people. Everybody wanted to be there. And we realized we're a team, not a bunch of individuals. And we know we can accomplish more when we work as a team, not as a bunch of people with egos wanting to do your own thing. And that's the great thing I like about working on big projects for NASA. It's a team effort. It takes everybody. No one person is more important than the other. You need everybody to make it work and to be successful. And if you play any sports, I'm more familiar with football. That's my favorite sport. Or if you soccer, whatever sport, baseball, everybody has a role to play on that team. And everybody's got to do their job. And no one is more important than the other. Everybody has to do it right, and you have to practice, and you have certain plays you run. And when you do this all together as a team, you win the game or you win championships. And the same thing with space flight. When you work together as a team, you achieve remarkable things, and you learn an awful lot about a planet in this case. So our goal as a team was to learn as much about Mars as we possibly could. And we took every day as a gift because tomorrow may not be here, and that goes for your everyday life. I mean, you take every day, you only have the present. The past is gone and tomorrow may never arrive. All you have is what you have today. And that's a good way to live your life. And that's the way we kind of figured we would explore Mars. And another thing that was interesting is scientists and engineers, you may or may not know this, scientists and engineers usually don't get along too well. They kind of butt heads because they think differently. And I have a brother who's an engineer and we just think differently. It's simple. Scientists want to know scientists want to know why, engineers want to know how. And so in our project, the scientists learned to think like engineers and vice versa. And I think that helped us get along and work better. And one of the reasons this mission lasts so long, I think, was the team, but also obviously the rovers were a great design by the engineers who built them. Next slide. Well, my office was on Mars. I went to work on Mars for 15 years every day. And I worked on both rovers, and it was just a lot of fun. It was the highlight of my career. So at this point, to worked on 2 rovers on Mars, and I was really fortunate because I got to name all the craters we explored, and it all happened by accident because the night before we landed Spirit, it landed first, and then Opportunity landed 3 weeks later. We had an all-hands team meeting, and I asked, what are we going to name things? Because we got rovers, we'll be driving around seeing new scenery. And Steve Squires, our science team leader, said, I hadn't thought about it, but you're in charge, So I was like, it was kind of fun. And I got to name all the craters, and those crater names will be there long after I'm dead and gone. But so the craters in Opportunity's landing site, Meridiani, they were all named after famous ships of exploration. And because I wanted to tip our hat to all the famous explorers who came before us that allowed us to be where we are today. And these 2 rovers, it sounds crazy. They're machines, but they were like my friends on Mars. And when you work with something that long, you get attached to it. And it was kind of weird. And it's been kind of weird that now both those missions are over. I still kind of have withdrawal symptoms. I want to kind of get on my computer every morning and look at new pictures from Mars, from the rovers, but they don't come down anymore since the mission's ended. So it's been kind of an interesting time after being involved with these things for all these years to no longer be working on them. Next slide. And no matter what project you do, if it's flying to Mars or doing a project in school, you have to have like a goal or a mission statement. And usually it shouldn't be any more than 1 or 2 sentences. If it's more than 1 or 2 sentences, then 9 times out of 10, you don't know what you're doing. So you should be able to do it within a sentence. Now, this is a long sentence, kind of run on, but it has a lot of adjectives in it. But this was our goal for our 2 rovers. And we were told to determine the aqueous, that means the water history, the climatic and geologic history of 2 different sites on the planet Mars, where conditions may have been favorable for life to have occurred. And so that's what we were told to go do. And we ended up doing a great job. Like I said, we had a great team and some great rovers up on Mars doing it. Next slide.
Hey, Jim, I wanted to give you a warning. We're about 35 minutes and we did want to open up for the kids in a little bit. So just be aware of time, please, because we do have to end.
Okay, I'll zip through next one. I'll zip through these fast. I already talked about a lot of this stuff anyway. Next slide. As our liftoff, next slide. Next one. Okay, Spirit landed in Gusev Crater, and you see these sols. And if you saw the movie The Martian, you're familiar with this term sol, S-O-L. That's what we call a day on Mars. And the reason we didn't call it a day is because it's longer than an Earth day. And over time, it accumulates and would wrap around, the days wouldn't be in sync. So whenever you have a day on Mars, you call it a sol because it's basically 40 minutes longer than an Earth day. Anyway, you can see where we landed at Sol 1, and then the driving we did to the Columbia Hills over there to the far right. And the rovers were only supposed to last 90 days, and we're only supposed to go 2,000 feet. The Columbia Hills, those hills you see on the far right side of this slide, they were almost 3 miles away. So when we started out, we weren't guaranteed we were going to make it, but we did, and that's where our biggest discoveries came from. Next slide. The picture on the right is Mars, and the one on the left is the moon, but let's concentrate on Mars right now. You see how that bright white stuff looks like flour or maybe even snow? Well, it's neither one. And the only way we found this because we had a bad wheel on Spirit. So even on this mission, when things went wrong, they went right for us. I always said that there's somebody upstairs looking out after us because we were able to make so many great discoveries, even when failure was looking us in the face. When we lost this wheel, the wheel wouldn't roll anymore. It locked up. It's like a bad grocery cart. But we drove backwards and we drug up the ground. And if we hadn't dug up the ground, we never would have made this discovery. And that white stuff is something called pure silica. Now, the only way you get pure silica on Earth or Mars is you have to have a lot of water, you have to have a heat source. And so if you've ever been to Yellowstone National Park, you've seen silica. You didn't know it, but you saw it. All those geysers, Old Faithful, that mound it squirts the water out of, that's made of silica. So this area on Mars, probably about 3.5 billion years ago or so, was where a hot spring was going off, or a geyser on Mars. And those are very favorable environments for life on Mars. Next slide. This is Opportunity. It landed in Eagle Crater, and all these craters here are named after famous ships of exploration. And we drove Opportunity 28 miles before it all ended. Next slide. And we were able to do our geologic history. So the oldest rocks are on the bottom, and those were ancient sand dunes. And then we had water, groundwater, and then streams up above. So we had lake beds on Mars there. And I know my time is getting up. Let's do one more slide. Next one. I'll do this next one. Keep on going. I already talked about all that. Keep on. And I've talked about that also. Next one. Next one. And next one. And next one. Okay, right here, that bright dot is the planet Earth. That is the first time the picture of Earth has ever been taken from the surface of Mars. And it's not a great picture. It's kind of grainy and pixelated, but our cameras weren't designed to work at nighttime. And that was a nighttime picture, and that was, doesn't look very significant, but if you were on Mars, it would have color to it. The Earth would have probably a bluish kind of color to it. And one more, let's see, next slide. Okay, real quick here, I'm gonna do these. This was a night we landed Spirit. We're celebrating, we're happy because we get to explore Mars. We spent years of our life getting ready for this. The next slide. But that room, that's the same room here. And if some of you out there don't go and study science and technology and engineering and math, we're not gonna have people qualified to sit in this room to operate spacecraft going to Mars or Jupiter or Saturn or wherever. So hopefully some of you out there will become scientists and engineers because we're gonna need you. Big time, because the next slide, I'll show you some things that are pretty sobering. 1/3 of the people that work for NASA are almost ready to retire, okay, in about 3 or 5 years. So not enough young people are going into these fields to work the space program. And this last slide, this really drives it home. Only 4% of the people that work for NASA are under the age of 30, okay? So we're really in need of a lot of young people to come in and do this work because a lot of us are going to retire and die, and we need people to come do the work after we move on. And I'll leave you this last point, and I'll take questions. During the Apollo program, the astronauts are usually in their late 30s, mid-late 30s, but the people in mission control in Houston, Texas, operating, keeping overlook of the mission and running it, their average age was 26 years old. So NASA has got really old over the decades, and it needs a lot of young people to come in there with your ideas and talents to spur us on and get us back to the moon and onto Mars. And with that, I'll take questions.
Okay, thanks, Jim. I really appreciate it, and that was really important and insightful. I really thank you for taking your time out. So we're going to, so how we're going to do chats is we're going to have you guys go into the chat room and ask questions. We've been monitoring it, and Christina will be helping us answer some of those questions. But we did have a couple first ones. This first question is from the Forks Intermediate School, and they wanted to know, do temperatures change throughout the year? And if so, how many degrees is it between winter and summer?
Yeah, well, you know, it depends on where you land on Mars. Just like the Earth, you know, the equatorial areas are warmer than the polar areas. But with our rovers, we were near the equator because we were solar powered. Opportunity was about 2 or 3 degrees south of the equator, and Spirit was about 15 degrees south of the equator. And we did notice a lot of temperature changes. And you're right, Mars has seasons, just like the Earth does, but they last twice as long. We saw temperature changes daily of about 100 degrees. And because nighttime gets very cold. The atmosphere on Mars is very thin, so it cools off very quickly. So at nighttime, we would be like minus 100, 110 degrees Fahrenheit. And sometimes in the daytime, in the summer on Mars, if you want to call it summer, but not our summer, it might get around 40 degrees above zero, 50. But it's a very thin atmosphere. And if you're down in the polar areas of Mars, it's 200 degrees below zero down there. So it depends on where you are on the planet. It's just like a lot like the Earth. It depends on your latitude and if your elevation also. But the temperature changes it's very common, over 100 degrees, you know, 140 degrees temperature swings daily. And that wears your mechanical parts out. It's very stressful on those, you know, computer chips and solder joints. So it's a very, very hard environment to live in.
Great. Elena Keys wanted to know, is somebody watching the rovers 24/7?
Well, when we first landed on Mars, we pretty much it was 24/7 because we were the top mission at the time. But as our mission went on years and years and years, other missions came and they had more priority, like Cassini and these other missions that came. But what you do as the years went on, what we would do is we would have a meeting. Early on, we worked 7 days a week because we only thought we had 90 days. But you know, in year 15 or year 14, we worked Monday through Friday and took weekends off. But if there was an emergency, we needed to come in and do something, we would do that. And early on, we lived on Mars time because these were solar-powered vehicles. And it wreaks havoc with your daily life on Earth because that 40 minutes accumulates every day. It's 40 minutes today, 80 minutes tomorrow, then 120 minutes the day after that. And it wraps around. So we didn't have, and we also didn't have constant communications with it 24/7. It just wasn't enough time on the Deep Space Network because other missions have to share that with the antenna. But what we would do, we would come in, say on Monday morning, on Monday we would plan for Tuesday, and plan for the next day. Now Friday would come around, and we usually had the weekend off. So on Friday we did a 3-day plan for Saturday, Sunday, Monday. So we came in on Monday, we planned Tuesday. So we did that for, you know, most of the mission. And our meetings would usually start on Pacific time at 8 a.m. We would have sometimes a tag-up meeting at 7:30 just to kind of do a quick analysis of the data that just came down, because the pictures from Mars would come down at all hours. It would just depend. And so sometimes I would be up at 3 o'clock in the morning looking at the pictures, because my job was to study the pictures and to figure out what's going on there, and to use that knowledge to help direct where the rover is going to go. So yeah, you really didn't have 24/7, but we had as much as we could be communicated with daily though.
Great. Nathan M wanted to know, how was the Mars 2020 landing site chosen?
Yeah, I was involved in that. It took 4 years. It takes years to pick these sites. And what you do, you go to a meeting, and as a scientist, you bring in a site you think is very interesting, and you know, obviously you think it's one of the best sites to go there. And you get up and you present your scientific evidence. you're kind of like a salesman in a way. You got to, you got to sell the engineers and the scientists on it, because people take votes on it. And it's a long process. And we started out with, I think it was 4 years in the process. It just ended last October. And so a little more than a year ago, but we started, I think it has like 60 something sites. We ended up with final 3. And at the final meeting, we had the 3 sites, and we presented, and the scientists there and the engineers, they vote on it. And at that point, they're all good sites, but you can't go to all 3. You only have 1 rover. And the site that was picked was Jezero Crater. That's where it's going to land. It's a crater, and it has a delta. So it was an ancient lake a long time ago. And the rover's going to land there. And my site was one of the final 3. It didn't get picked, obviously, but I think Jezero will be a great site. My site, personally, I was on a team. We wanted to go back to the Spirit site, because Spirit already found all this interesting stuff, like where those geysers and hot springs were. We wanted to go there and pick those up, because these samples are going to come back to Earth one day. But most people didn't want to go back there. They wanted to go somewhere new, so we didn't win out on that one.
Okay, great.
Hey, Robert.
Yes.
Are you ready for the questions I've saved?
Why don't you go for them?
Okay. A student from Oregon asks, what are the main differences in soil composition between the soil on Mars and the soil from a similar area on Earth, like a desert or near a volcano?
I would say, if you go to a volcanic site on Earth, there's a lot of iron in the soil. Basalt is a lot of iron. But Mars would have a little higher percentage of it, and a lot more sulfur than a typical area on Earth. There's rocks on Earth that have sulfur, but the rocks on Mars are just loaded in sulfur and iron sulfides. And there's sedimentary rocks we studied there. They're sandstones, but they're not like a sandstone on Earth. Sandstone on Earth are mostly made of quartz, sand. The sandstones on Mars are sulfate sands. So once again, the sulfur again. So the biggest difference would be the iron and the sulfur would really jump out at you. Earth rocks have more aluminum in them than Mars rocks, but the biggest would be the sulfur and the iron content.
Thank you. Okay, so Susan Stuffer from Idaho asks, do you remember anything that particular teachers did or said that made a big impact on your decision to go into a STEM field?
No, because it's something I always wanted to do. I grew up when Apollo was happening, and it was always in the news. And then, being as a 10-year-old kid, walk out in your backyard and look up at the moon, know 2 Americans are up there walking and working. That does something to you. And I had a couple teachers. I remember their names. I won't say their names, but these are the bad teachers I had. I remember they told me I was too stupid. I would have never worked for NASA. I remember them very well. And I was raised not talk back to my teachers, so I didn't say anything to them. But I'm thinking in my mind, you don't know anything about me. You're not going to decide the rest of my life for me. I'm going to do that, not you. And so luckily I had that in me, because when you hear something from an authority figure, when you're growing up, you think they know best. Well, usually they do, but not always. I mean, like I said, these 2 teachers in high school, they told me I would never work for NASA. And if I'd listened to them, I would have given up, and I never would have been able to do what I dreamed about doing. But like I said, those are the exceptions. By and large, I had good teachers. And my parents, I remember when I first told them I wanted to do this, they were like, what is this? How do you do this? I never heard it, And they just told me that in this country, you can do whatever you want, but you got to work for it. And I think that's true. And but I had, a real good teacher, a science teacher named Mr. Hall. I do remember his name too. And he just made science interesting. His classroom was full of fossils and, animals in aquariums and rocks and everything in there. It's like going to a science museum. And he was an interesting teacher. He just made the class so interesting. And he had a lot with me going into geology. We went on field trips, to look for fossils. And he's one of my favorite teachers, yeah.
Oh, thank you. And then the next question is from Nathan, and it says, which NASA unit did you work at?
Well, I was at NASA Goddard Space Flight Center. That's outside of Washington, D.C. I also worked for the United States Geological Survey astrogeology headquarters in Flagstaff, Arizona. And like right now, I work for the Planetary Science Institute. That's a research organization located in Arizona. But scientists live all over the world that work there. And I've worked at Arizona State University where I got my PhD because some of the instruments were built there at Arizona State, and I worked on those. And also University of Arizona in Tucson, I worked down there because some of the cameras were built that flew to Mars there. So I've kind of been all over the place. My first job when I got out my PhD was at NASA Ames Research Center outside of San Francisco.
Great, thank you. Cole asks, does Mars have strong wind and dust?
That's a good question. And I mentioned the movie The Martian, because if you've seen the movie, you know, well, if you haven't seen it by now, you're going to get a spoiler because you plug your ears up. But the movie's 4 or 5 years old. So if you haven't seen it by now, I don't know what you're waiting on. But the movie The Martian starts out with this guy getting stranded on Mars because a dust storm comes. Well, Mars does have winds, but they're not very strong. They don't blow people and equipment around like in that movie. So that part of the movie is very wrong. It was horrible science. It was bad. It was wrong science. But other than that, the movie was pretty good. But that started out was very bad. And the reason I know this because our rovers went through several dust storms on Mars, and the rovers didn't move around. They didn't do anything. They didn't even vibrate. Okay, and because the atmosphere on Mars is very thin, it's equivalent to being about 20 miles above the surface of the Earth, much higher than you fly in a commercial airliner. Okay, so the atmosphere up there is very, very thin, and because it's so thin, when the wind blows, there's not a lot of force behind it. Okay, not much dynamic pressure. So we saw dust storms with our rovers, and we saw a couple sand grains move. That's all, okay? And the dust moves because the dust is very fine-grained. That's what gets blown around. But no rocks move, sand barely moved, and so no equipment or people would move. Now, you'll hear about wind speeds in these dust storms at 200 miles an hour. That's true, okay? But it's not equivalent to a 200-mile-an-hour wind on the Earth. Our atmosphere is much denser, it's thicker, and so roughly a 200-mile-an-hour wind on Mars would feel like a 20-mile-an-hour wind on the Earth. So a big difference.
Wow. Thanks. Again, Francis asks, in the future, could I go to Mars?
You might be. I mean, I thought when I was working my PhD in grad school, I thought by now I would have had people on Mars, and it hasn't happened. It seems like it's always 15 or 20 years away. But yeah, you could be the first person on Mars because in your lifetime, you're going to see it happen. And unfortunately, I can't tell you when. You know, the moon, it was by the end of the decade was the finish line. And we don't have a timeline out there right now for Mars. The earliest it will happen will probably be the mid-2030s, 2035, 2037. That's probably the earliest. But things can change. And you have to be really optimistic in this kind of career field because, you saw the odds of landing on Mars aren't good. You have to be an optimistic person. But you'll see it in your lifetime. I wish I could tell you what year it would be. I wish I knew. I hope I get to see it before I pass on. But you'll see people on Mars, and you have a good chance of being an astronaut or being a scientist or engineer to make that happen. That's why I would encourage you, those of you who are interested, go into the science, technology, engineering, math fields because, I showed you the slides. NASA's going to need people, and you'll have ideas that we haven't even thought about. I mean, for instance, y'all grew up with computers. I didn't see a computer until I was in college, okay? So that's an insight y'all have of a way of attacking problems and doing things that my generation didn't have. And so whenever you get younger people in there, you're going to be fresh ideas and ways of doing things, and you'll have certain skills and talents that don't exist right now, and they're going to be needed. And so yeah, you very possibly could be the first person on Mars. It's not impossible. Somebody's going to do it.
So Christina, ask two more questions. I think we're going to got time for 2 more questions.
Okay, and good, because this one, I can combine 3 different questions from Nathan and the new Von Brahms. They're all asking about similar things. It says, how was the Mars 2020 landing site chosen? What's interesting about the Jezero crater? And what does the alluvial fan tell us about the climate? Okay.
The landing site, I didn't mention this earlier, but the landing site, it took years to decide, and you try to find the best science site for the instruments on the payload for the rover. But you also have engineering constraints, like it has to be a certain elevation because it comes down with parachutes at first. So you want to be lower elevations to use as much atmosphere of Mars you can to slow you down. So you want a certain elevation. You want certain slopes. You don't want to land on a steep slope and have the rover fall over. So it has to be fairly flat, not perfectly flat, but fairly flat. You don't want it too rocky because then you land is, you get a lot of boulders could crash. So it has to have some rocks, but not too many rocks. And also dust is a factor. You don't want to have it too dusty because when you land, all that dust gets blown up on your instruments and stuff. So dust is a factor, rockiness, slopes, elevation, all these factors come in kind of for safety or engineering constraints. So those factor in very heavily in determining landing sites. So the landing site has to be safe, first of all, no matter what the science is, because if you don't land safely, you have no mission. So safety is number one. And then science kind of comes in. You have to have good science to do there. So that all factors in. Jezero was selected because more people thought that was an interesting site because it used to be a lake bed in there. And there's not an alluvial fan there, it's a delta. Now there's a difference. I don't know if you're asking the difference, but I'll tell you anyway. Deltas only form underwater, okay? So the fact that there's delta there means there had to be a lake. You probably heard about the Nile River Delta, Mississippi River Delta. Deltas are landforms where rivers carry eroded sediment, rock and dirt, and drop it out underwater. Now alluvial fans don't happen underwater. They happen they're called subaerial, under the air. So there's a difference. That tells you an environment was different. There are alluvial fans on Mars, but Jezero has a delta in there, is why that was picked, because it indicates there was an ancient lake bed there, and we can go to the delta and look for any possible signs of fossils and stuff in there, and also learn about the climate on Mars when this formed. And but yeah, you're correct. There are alluvial fans on Mars, but it's not an alluvial fan in Jezero. It's a delta. They look similar.
Thank you so much.
But they're different environments they form in.
Robert, do you think we have time for one more? Are we done?
Okay, this will be the last question, and then if you guys, yep, last question.
All right. Nathan asks, are we still looking at practicing terraforming on Mars at some point in the future, or has that idea been shelved?
It's a long way down the road. I mean, people talk about it. It's more a theoretical type of thing. Basically terraforming is planetary engineering, and we're not very good at that, and one thing you learn in science, never say never, because eventually you'll be proven wrong. Terraforming could happen, but I think that's definitely easily hundreds, if not thousands of years from now. I mean, to get in there, I don't even think we have really the knowledge of how to do this. This is something that needs to be worked on. It's a field, if you're interested in, to go in and study. And it can be used in small examples, like if you go to land people on Mars, you got to keep them alive. So in a way, you're going to do terraforming inside, if they live in a dome or something like that, a habitat. You got to learn how to keep them alive and things like that, live off the land. So there's useful information. In terms of planetary, the whole planet Mars being terraformed so that we can go there one day and walk around in short sleeves and breathe the air, that's really still the realm of science fiction. A long way down the road, but as I started out this talk, science fiction inspires people to make science fact.
Okay, Jim, I really appreciate that, and I think everybody online here appreciates your time. We're going to post it for other teams to have a look at it, and for all you team guys, good luck in your developments, and I hope that you are successful in your efforts through the challenge. So thank you much, and we'll end the video conference right now. So thank you.
Bye-bye. Good luck.